Hi there, I'm Mr. Nichols, and this is an introduction to motion diagrams, another way to represent motion in your physics class. Now, what is a motion diagram? When you take a look here, you can see that they're a way to draw motion without using graphs. So we've got graphs, we've got words, now this is another tool to add to our tool belt. If you look at a picture like this, kind of like we do in Pivot, you can look at the car at different points, and if you take a snapshot of it at each of these different locations, you'll look at something like this. They'll be evenly spaced out if a car was traveling at a constant speed. And a motion diagram uses some symbols. What symbols do we use? We use a dot to talk about where the object is, and an arrow or a vector to show where the object is going, how quickly it's moving, its velocity. That's what these mean. So just a dot shows where it is. With the arrow, that tells us the position and the velocity of the object. This is pretty simple. If an arrow is small, it's going slow. If the arrow is big, it's going faster. And the direction just tells you which way it's going. So back to our car at a constant speed, the motion diagram looks like this. It's moving at a steady pace. All the arrows are the same size, and you can see that the dots are equally spaced out. When we look at a faster moving car, if the car is moving faster, the car itself is more spaced out, you'll notice here, as well as the dots are more spaced out, and the arrows are larger than they were on the previous slide. If the car is moving the other direction, to the left, then all that we have to do in this case is just reverse the direction. So it's still going fast, still long arrows, and far spaced out, but the arrows are pointing to the left. Now, if the object isn't moving, if it's stationary, then we don't have it move. You could just put the dots in the exact same spot over and over again, but it's kind of hard to tell how many there are. So we place them kind of like on top of each other to show that it was staying at the same spot for a long time. And this would show an object sitting still. You can kind of make these go upwards or really downwards. Either way would work just fine. So now it's time for you to try to draw this motion diagram. So a train moves to the right at a slow and steady speed for 5 seconds. So pause the video here and give this a try. All right, so hopefully you've got this one drawn, and it should look something like this. 5 dots moving to the right, equally spaced, same length, short arrows, something just like this. All right, how about another? We've got a speedboat that moves towards a reference point, fast, constant speed for 3 seconds. All right, so it's moving in a straight line, constant speed for 3 seconds. I'll give you another second to give this a try. Pause it here. And we continue. There we go. So this time it's moving back towards the left. This one didn't specifically state the direction, so if you had it going the other direction for this one, that's just fine too. Let's take a look at this one. Give this one a try. We'll give you this one is not moving, so it just looks like this, 6 dots in the same spot because the starfish is lazy. Now we've got one more practice for you. This one's got a few different parts of the motion, so we're trying to translate these words into a representative diagram. So we've got Miss Drost staying at her desk at the starting point, walks slowly to the door, stops at the door, waves hi to the teacher in the hallway, Miss Fulling, and then walks quickly back to her desk in 2 seconds to get her coffee. So she starts and ends at the same place, stops for a while, and comes back. Let's see what that looks like. I'll give you a chance to give it a try and see if you can figure this out. All right, let's see if you got it. Something like this. So you can see, in this case, we've got a dot and 3 seconds of walking over towards the door. She gets over to the door and waits there for 3 seconds, and then has 2 seconds to walk all the way back to where she started. You could have this going to the left or the right, because it doesn't really say which direction that she's moving in this problem, but there's your example. All right, so we looked at objects moving at constant speed. Now what we're going to look at is what happens if something's accelerating, if it's not moving at a constant speed. So in this example, we've got a person that's speeding up. They start off at the beginning moving a short distance, then a slightly farther distance, then a slightly farther distance, up until the end when they're moving a pretty far distance in that second. And so you can look at the picture, this sort of stop motion picture like what we would see on Pivot, or you can draw a motion diagram with those dots and the arrows on the bottom. The arrows get bigger as time goes on. This is an object speeding up. And we can also get the opposite, an object slowing down. At the beginning, it's going really fast. Just like this, it's got long arrows, big space, shorter arrow, shorter space, shorter arrow, shorter space, and then a really short arrow at the end as it slows down to eventually stop at the end. So we talked about what these all look like on the graphs. Now we're looking at them with the motion diagrams. We can also think about the wording that we use. These are sort of our 3 different ways that we have to talk about motion in general. Now, last question about this is like, what do these ones mean? Let's get a little bit of practice with these. So we've got 4 situations here. We've got an object moving to the right, and we want to know which one matches these here. So pause the video here, and we'll see you back in just a second once you've thought about how these match up. All right, let's go ahead and take a look at this situation here. We've got our 4 objects. Hopefully you've had some time to think it through. We're going to have one object that's going fast at a constant velocity. So constant velocity means that they're equally spaced out and that they're far away. This one, number 2, looks like a prime example for moving fast at a constant velocity, because you can see that these are equally spaced out as time goes on, and they're pretty far spaced out. Now, if we want to see one that's also equally spaced out, let's take a look at number 4. That one seems to be equally spaced out, and these are nice and close together. So these 2 examples, I think, show us constant velocity. Now, the other 2 we can look at speeding up and slowing down. And I think we can see that if the object is moving to the right, that number 1 would be speeding up, because we start off with really small distances. Those distances get bigger and bigger and bigger and bigger. So if we were to draw this as a dot diagram, we would draw a dot with a little arrow, followed by a dot with a slightly bigger arrow, and so on and so forth until we got all the way to the end. And number 3 then would be an object that's slowing down, as long as the object is moving to the right. Now, one last thing you could think about is what would happen if instead these objects were moving to the left? Would any of these other answers change? Now, hopefully you can see that 2 and 4 would still stay the same. They're still our constant velocity because the spacing doesn't change. But what would happen is 1 and 3 would switch around, because this would show an object moving this way, starting off fast and getting slower, and this would be an object moving this way, starting off slow and getting faster. So these sorts of diagrams, this is kind of the reason that we also draw the arrow, because it tells us which direction it's going and it helps us know exactly what's going on. So hopefully that made some sense as we're looking at these dot and line diagrams. These are called motion diagrams, and it's our 3rd way of representing motion. We've got words, we've got dots diagrams or motion diagrams, and the graphs. And what you're going to have to do is translate between these. You can see something written as words and turn it into the graph or the dot diagram, or any combination of those. So good luck with that. We'll see you in class.